All right, Jason Ryan, I'm here with Justin. Now, Justin, tell me who's part of your team. Tell me who you're with. Just give me a basic rundown on what we're looking at today.
All right, well, my name's Justin. I'm from University of South Florida, over in Tampa.
Right.
I'm a chemical engineer. I'm helping out with GPS on the receiving side, making sure our data's coming in.
Okay.
This is Jaime. He's also helping me with running the computers on our GPS side. He's learned about all of the different coding for the GPS. He knows what it all means. Any problems we have, he can tell us what's going on.
So he's your tech guy.
Yep. Well, yeah, he's one of our tech guys. We're all
one
tech
of your
guys
tech guys.
Here,
We're all tech guys.
We got
okay.
3 tech guys.
Who's the tech girl?
That is Shivani. She's one of our camera women over here. She's got live streaming video on one laptop. She's got a VCR receiving video, recording video on the other one. We've got a monitor here that comes out to our antenna, which is operated by Lanice.
Okay. This is Lanice over here.
Yep.
Let me say hi. And if you look over here, folks, you'll actually see they're getting the balloon ready for launch. Now, Justin, who are you here with today?
Florida Space Grant.
And you're going to basically launch. Now, if I understand correctly, there's actually a camera mounted on the balloon.
Yep,
so we're going to get video coming back as it goes up.
Correct. And the camera has 2 views, one straight down and one 90 degrees out, so you can see the horizon, curvature of the Earth, and then one straight down so you can see Florida.
Whoa. Curvature of the Earth. You're going to get that high?
Yep.
How high is high?
100,000 feet.
You're going to go to 100,000 feet today?
Hopefully.
Well, I don't think there's going to be any hopefully because you guys are USF students. I'm a former USF guy, so I got to say, wish you the best of luck today. We're going to wander around and interview people, get some more shots. Just keep us surprised throughout the day about what happens, okay?
All right.
All right, Justin, thanks a lot for talking to us.
You're welcome.
So everything's working out for you great right now.
Everything's working out great right now.
Now, is there any surprises that you've seen take place so far?
We had a second where we had some garbled data, and we just changed a few settings, and it came right back up.
So basically, you worked the problem in real time and solved the issue.
Yep.
Well, good luck with the rest of your mission, and good job.
Thank you. It needs to be like exactly in line with it, so maybe like...
All right, I'm joined here by Shivani, and Shivani, she's going to tell us a little bit about what your role in all this is today. So just tell us a little bit about what you're doing.
Right now, I'm using a computer program called Hyperterminal to monitor our temperature inside of our box that holds our camera and our transmitter. And I'm also monitoring the live stream right now. That's streaming live on livestream.com.
Right.
So we'll be able to see what the camera is seeing right now.
Now, why are you monitoring the temperature inside that box?
To see when, if and or when the camera stops transmitting, we know if it's because of the temperature or if it's because of something else.
Ah,
So
okay.
if the batteries get cold enough, they'll stop working and the camera will stop working.
So basically, your role here today is both communications as well as technical aspects of the mission itself. And you're out of the University of South Florida?
No, I'm out of the University of Miami.
We won't hold that against you, but thanks for talking to us today.
No problem.
Yeah, it got big. It got a lot bigger.
So, it's kind of like the magic smoke.
So I'm talking to an engineer here, and he's talking about how we just heard that the balloon is landing. And that's because the pressure is increasing, right?
Right, the sensor that's on the balloon is sending down pressure data.
Now, how is the GPS feeling at the moment?
Well, apparently GPS isn't very happy.
It's very unhappy at the moment.
It's not locked up at all.
Now, so is it potentially when it gets in the lower atmosphere, it can be detected again and it'll lock on, or is that potential we may not know?
Well, we'll have to see. It depends on what happened. If it's something like if the GPS antenna disconnected from the unit,
Right.
it won't come back. We've had some GPS units that, because of ITAR regulations, they're restricted from operating above certain altitudes and velocities.
Correct.
So the people that maybe we wouldn't want to say strap a cheap GPS unit onto their Scud missile and suddenly have 3-meter aiming accuracy. So there's restrictions on GPS units. We usually try to get the ones that are not restricted. You have to make some special promises not to let other people have them.
Well, that's usually a good thing, though.
But so we'll just see as it comes down, and we'll see if we start getting
Good data.
fixes again. We're not. We're getting data from it, so we'll just see what happens as it comes down.
Thank you. I'm with Tony Gannon here from Space Florida, and I was sitting down chatting with him, and he was telling me a little bit about the details about what it takes to do what from the outset looks simple. But Tony, it's not really that easy to pull one of these things off for this educational outreach program today, is it?
No, it's not simple at all, but it takes teamwork. It may be an old cliche, but it is very, very true. I was mentioning to you earlier, about 7-8 years ago, Space Florida, or the predecessor organization,
Yes.
NASA Kennedy Space Center, and the Florida Space Grant Consortium decided we would pull together a very unique, a truly unique program called the Academy. It's since renamed the Space Florida Academy.
Okay.
And our effort is to provide students, particularly undergraduates, you might say real world experience, the kind of thing that they would do if they worked in the aerospace business.
Hands-on.
Absolutely hands-on. So they're involved in the construction and the design of payloads which will fly on scientific balloons to altitudes of about 20 miles high, 30 kilometers.
20 miles high.
20 miles high.
That's a third of the way to space.
Absolutely. About 3.5 times the altitude that you fly on board a 747 jumbo jet. That's quite high. At that altitude, about 100,000 feet, you can see the curvature of the Earth, if you were there, the blackness of space, and even stars in the sky. So typical payloads we'll put on board will be, as I say, the camera, the live video camera, a GPS, so we know where this balloon is drifting across.
Right.
Some of them have gone to very remote areas in the United States, Louisiana, some up to the northeast. One we know for certain landed in the Azores, a small series of islands about 800 miles west of Portugal.
The Azores.
The Azores, west of Portugal.
Now, is that where it stopped and landed?
It
touched
landed
down?
on a beach in the Azores, was picked up by a local who later called me because students have this really bad habit of putting my business card into the payload. So I get a call in Portuguese several years ago asking me what's up. And coincidentally, I had my sister-in-law on board in my car with me, with my wife, and she speaks Portuguese because she'd lived in Brazil.
Well, that was a godsend that day.
Absolutely, it was amazing. We had a long conversation, and we decided he would interchange. He would send me photographs of the payload as it arrived. I sent him photographs of the students before they released the balloon, and we put in some goodies too, a couple of T-shirts from Kennedy, some
Well,
space
yeah, he contacted
paraphernalia.
you already from Portugal, so the least you can do is give him a T-shirt.
Absolutely. What's kind of funny about it, so when he discovered it, it was his dad discovered it on the beach, and
Right.
in his mid-80s, he thought maybe it was from Mars or Venus or some planet.
Right.
So we had a wonderful conversation through an interpreter. But that was just to give you an idea. 20 miles up there, and we don't know where that payload's heading.